Let me have water. Some circular motion idea is what we are trying to bring. Let me finish off the content here only. And now you see that what is telling the detector is stationary at 2 hours. Here's the detector. Huh? There's a detector. So we'll put it some red color. There's a detector. And I have to draw the diagram. Two cases are there. Now, where is the detector? Detector is here. There's a detector. Then what about source? Source is moving in a circular path, in a circle with a constant speed. Then, so what is the question? Something is asking. The first diagram, let me take it. So the source, let it move in a clockwise sense, so it will be here. So when the source is here, so how the velocity of the source should be tangential and detector is at rest. It will generate a wave. And by the time it arrives here, it will become f dash. Okay, this is some basic condition. No, similarly, what happened when source is receding away? I should draw a tangent to the circle, no? Yes. No, how the source is here, and it will have velocity. So in this case, it will generate a wave. Now also it will generate a wave. So when it generates a wave, that wave will be received by the detector. F2, let me write this is F1. So this is R, this distance is 2R. Himself in the given theta. So definitely what happened, this should be 30 degrees, 60 degrees. This will be 30 degrees. Find the frequency emitted by the source. The frequency emitted by the source is Fs. Is asking what are the coordinates of the source when the detector records the maximum and minimum frequencies. And what are that maximum minimum frequencies? So let me put question. Find the coordinates of source when the detector detects maximum and minimum frequency. And that values also and corresponding frequencies. Okay, no, so definitely I think it will be here only when the source. So when the source is at a point on a circular path where the line joining the source and detector becomes a tangent to the circle. Here, how the velocity of source will be directed along line joining source and detector. What about here? When it is here, how they are perpendicular? No, sir. What about here? Yes, it will have some velocity. Then this will be the source line joining the source and detector. Component of velocity will come here. So when it will be maximum minimum, when the source is at a point on a tangent. So what is this? This will be a tangent. Okay, now we'll write the Doppler effect formula. So what is the Doppler effect formula? F1 is equal to F into V by V minus Vs. Now why V minus Vs? Source is approaching the detector. Here, what about this? F2 equal to Fe by V plus Vs. So which will be maximum? This will be maximum. This will be minimum. Sir, what about if the source is here? If the source is here, check it. Only when this is the maximum possible thing. This is a minimum possible thing. So we know speed of the sound, we know frequency. The speed of the source is given. How to get these coordinates? So this what origin I'm defining. How to get coordinates? I think the coordinates can be obtained from here. What are the coordinates? This will be r cos 60. This will be r sine 30, r sine 60. So what are the coordinates of this? Point P1, P2. So coordinates of point P1, what you can write? R cos 60. Okay, I agree this. So something, source will be moving in a circular path, detector will be placed at a certain point, and something is related to that, what the question is being asked. So nothing will happen to the source will continuously move. Sir, why you directly took here? Why can't it be here? So somewhere here you check it now. The velocity will be tangential and the line joining will be somewhere here. So that the angles will come. So if any angle here come, Vs cos theta or something, no? So then this cannot be maxima. Okay, do calculation. Let me take the next.